All right, number 50, chapter 18. So here we have 3 resistors. I'm going to say some stuff I already said, but I just started recording it. We got 3 resistors, 1 capacitor, and we're asked to find 2 things. We're asked to find the current in each resistor and then the charge on that capacitor. Now, the first thing you got to realize is that we have a capacitor on this branch, okay? Wherever you have a capacitor, that represents a break in the circuit, which means that there's no current flowing through there. Does that make sense? So you look at this and you go, okay, this entire branch over here, this entire segment over here gets no current because there's a capacitor there. So we already know the current in this resistor here is going to be 0, right? So really nothing's happening there. What's the reason for that resistor being there? Just to trick us, to confuse you. Shh. Okay, so, oh, and then this switch. A switch, it's just an easy way to turn a circuit on and off. So they're telling us here the switch has been closed. So really, it's just like that, okay? So the current comes out of the battery. The current comes out of the battery, goes like this, comes back around again with no current over there, okay? Which means for all practical purposes, this resistor and that resistor are in series. Now, how do you simplify resistors in series? You add them together. So our total resistance across, so from here, if this is a 9-volt battery, we're saying 9 volts and 0 volts. So like this point right here is 0. This point right here is 0. How many volts do we have up there? 9. So as you go from this point across these 2 resistors, what's the delta V across those 2 resistors? 9 volts. What's the total resistance? 27,000, right? Because kilo is 1,000. 27,000 ohms. So to find the current, we use Ohm's law. Delta V equals IR. So I is delta V over R. So that's going to be 9 volts over 27,000 ohms, which gives us a current of 0.0003 repeating amps. And you could just call, if you want to be cool, you could just call that 0.3 milliamps. Okay? So that's the first question. That's A. So we found the current here is 0.0003 repeating amps, and then the same thing with this current. This current here is 0.0003 repeating amps. Okay, any questions with that? Now, part B. Part B wants us to figure out the charge on that 10 microfarad capacitor. Okay, so we go to this capacitor. Now you got to know the definition for capacitance. Capacitance is defined as charge over voltage. So if we're looking for the charge, Q is the charge, we go capacitance times voltage. Okay, the capacitance is 10 microfarad. Now hey, from Friday, who remembers what a farad is? Coulomb per volt. So look, you can just leave the micro there. I would just leave the micro there and then plug in Coulomb per volt. So this is 10 microcoulombs per volt. Does that make sense? So that way you don't have to get into the 10 to the negative 6 business. Okay, now, the thing we got to figure out, how many volts are across the capacitor? The number one way to tell me on the quiz, the number one, if you want to tell me, like, hey, Spaldo, I really have no idea what's going on. There is a real good way to tell me that you have no idea what's happening, and that is to take the voltage of the battery. See, because kids that don't know what's going on, they're like this. They're like, ooh, wait, there's a V. Oh. And they just plug it in like that. Right? Is the voltage across the capacitor, is that going to be 9 volts? That's the voltage of the whole circuit. So how do we figure out how do we figure out the delta V across the capacitor? Well, look, you could figure it out like this. So look, 9-volt battery, that means 9 and 0. Hold on 1 second. So where was I? Oh, we're finding the voltage across the capacitor. So here's how you do it. 9-volt battery means 9 and 0, right? So look, you cruise up here. How many volts do we got right there? 9. So you keep going like this. Now what's going to happen across this resistor right there? We're going to lose volts. So how many volts are we going to lose across that resistor? Can we figure it out? Yeah, because delta V equals what? IR. You take the current times the resistance, and remember that 12 is really 12,000, right? Plug it in as 12,000 ohms. You're gonna get, hold on, 4. This comes out as 4 volts. So how many volts do we have at this point right here? Not 4, 5. Because look, 9, we lose 4, which brings us to what? 5. So how many volts do we have right here? 5. Now let's do the other side. So right here is 0. So how many is right there? 0. How about right here? 0. Because remember, what's going on in that resistor? Nothing. That resistor has no current, right? So what's the delta V? What's the delta V across the capacitor? 5. Right? Boom. The volts cancel. So Q, that's 50 microcoulombs. Bam! You like this, don't you? Any questions? Alex?
So if you had like a light bulb after a capacitor, it wouldn't turn on?
Because there's no current through it. Yep.